Would you ask Dr. Stoianov to come back in, please? Thank you. All right, Dr. Stoianov, ready to carry on?
Yes, I am. Thank you.
Thank you very much. Yes, Mr. Kinnear.
Thanks, sir. Before the break, Doctor, we were searching for a diagram which showed all the hydrants. We think we found the diagram to which you were referring, and so could we look at ISTRP quadruple 0 treble 0 8 /219. And if the diagram figure 6-114 could be expanded. Sometimes these things take time, so don't worry.
I appreciate this.
Thank you. That shows, I think, the hydrants which we were discussing before lunch. And I think in the centre we see FH1, and immediately below that is a circle with two bits coming off it. That's the private hydrant, is that right?
Correct. Just first of all, what this figure shows is the hydrants which within the area of Grenfell Tower. All the hydrants I considered in my analysis are within 300 meters from Grenfell Tower on this diagram.
Right.
And the assumption was that these hydrants could be accessed with a pump relay, with a single pump relay, very much as LFB has done. Just a little bit more context to this diagram and the analysis. Clearly, the diagram also assumes that, and the analysis also assumes that we have some estimates about the flow coefficients of hydrants, which normally should be a regular practice of flow testing. So that's one aspect. And the second aspect, what it does, it runs the analysis for loading conditions or for demand, which first of all take into account a standard PDA procedure of LAB, predetermined attendance procedure, which includes a single aerial appliance for high-rise buildings. So in other words, what I assume for these 7,500 liters per minute is that I have one aerial appliance of about 2,400 liters per minute. Let's assume that they have to deploy also a ground monitor of about 1,600 liters per minute. Then there needs to be about 1,500 liters per minute for internal firefighting. So this is very much, I would imagine, a reasonable assumption to assume that if a PDA includes that appliances, we need to have sufficient flow rate to fully deploy these appliances. And that's why the 7,500 liters per minute come from for this first analysis. The second figure...
Dr. Stoianov,
yeah.
My question some time ago now was simply to confirm the diagram.
It is.
Thank you. I want to sort of return back to where we were, Doctor, and deal with, the assessment of whether higher flow rates could have been achieved. I think some of the points you're adverting to now, we can better address in a more focused way as we go through that particular topic. Now, could we go back to ISTRP quadruple 0 treble 0 8 /218. Now, this is an extract from your report, and it sets out some points which are relevant to the assumptions that you made in the assessment which we were discussing before the break and which you've been touching upon again. And what it sets out there under the heading 6.8.12 Assessment 2 Assumptions is this. It is important to note the limitations for this assessment. The estimated flow figures scenarios above, the flow rates of 7,400 and 12,000, which the assessment tested, are for illustrative purposes only. to assess from the perspective of the water distribution network whether it would have been possible to supply those flow rates given the hydraulic conditions in the network. None of the above should be interpreted as any suggestion on my part as to which appliances or equipment LFB could or should have deployed on the night of the fire, those being questions far beyond my expertise and the scope of this report. The assessment further relies on the following factors. 1. LFB having up-to-date knowledge of the operational status and flow discharge characteristics of fire hydrants. Based on flow tests of fire hydrants, this does not appear to have been the case at Grenfell Tower. 2. LFB using multiple fire hydrants to supply water to individual aerial appliances, e.g. LFB setting up pump relays as done for fire hydrant H8. 3. Thames Water, TWUL, providing expert engineering guidance and support to LFB, including the use of a hydraulic model and near real-time hydraulic telemetry data. Now, in addition to the factors and assumptions listed there, is it also important to make clear that you don't know about and cannot comment on whether it would have been logistically possible or operationally feasible for the LFB to have used the specific optimum combination of the specific 10 hydrants identified by this assessment in order to achieve those flow figures?
Correct.
So, for example, some of the hydrants identified may not have been in operationally suitable locations due to access problems or other difficulties which are understandably beyond your knowledge and expertise.
Correct. As I said, this is an illustrative example of a process that analytics that could have been deployed.
This assessment was calculated using a complex mathematical model which you validated and refined following physical testing carried out after the fire. Is that right?
That is correct, but I also have expectations that water utilities should, and they do, that sort of level of analysis on a regular basis.
Now, the mathematical modelling you used also factored in the flow coefficients of the hydrants at or near the tower, which you were able to calculate following a series of tests you carried out in 2008. Is that right?
2018. Yes.
18, sorry, apologies, yes. And that data, of course, wasn't available to anyone on the 14th of June 2017.
No, but that's absolutely correct. But as an engineering judgment, I can make certain assumptions about these flow coefficients if I'm faced with the need to run that sort of level of analysis.
Whatever data was available at the time of the fire, for quite proper reasons, you're not in a position to comment on whether it would have been practically possible for Thames Water to carry out these kind of complex mathematical modelling and hydrant optimisation calculations in real time in the midst of the incident in the early hours of the 14th of June 2017. Would you agree with that proposition?
Not entirely, no.
Let's take it in stage. What do you agree with then?
I agree that running probably a complex, formulating this as an optimization problem might have been beyond the scope and knowledge of Thames Water on the night of the fire. But equally, the problem what I'm describing could have been enumerated manually. In other words, Thames Water had access to a hydraulic model. They had access to near real-time telemetry coming from their system, and that would have been sufficient to run the hydraulic model and manually almost pick up hydrants and demonstrate that larger flow rates could have been extracted. They might not have been optimal defined in mathematical terms, but they would have been far greater than what was achieved on the night of the fire.
If Thames Water had been able, for example, to carry out an exercise in mathematical modelling and hydrant optimisation calculations in real time in the middle of the incident, and were indeed able to communicate the ideal combination of hydrants to the LFB, that would likely have required the LFB to completely reorganise its water supply setup midway through the incident, which of itself would have caused disruption and delay. Again, would you agree with that proposition?
I agree that would have required LFB to change their operational strategies, but I wouldn't go as far as stating that this would delay activities. So I don't know how that conclusion can be drawn, that this will delay activities, because if we looked, and I'm just observing facts here, by no means this is part of my competence, but if I look at the statements based by Incident Commander Rowe and Lachlan, they completely dismissed the role of the use of water in the firefighting operations.
But is it fair to say that looking at the assumptions you yourself have set out in the report and the limitations you've fairly conceded there, the answers you've again fairly given to the points I've put to you just now, that the results of the assessment about flow rates are what was theoretically could have been delivered from the water distribution network in optimum hydraulic conditions, and they don't allow us to draw any safe conclusions about what flow rates the LFB in Thames Water could or should have achieved on the night?
I guess yes.
Can I now turn to a separate topic, which is...
Just before we move away, can I just also note that the analysis I carried out was carried out for peak demand. And that prompted me because the Network Management Centre of Thames Water raised serious concern that as demand picks up, they will have significant problems. So I ran that analysis on the worst case scenario, which was the morning peak demand at 8 o'clock in the morning.
Thank you. The next section I'd like to turn to is whether regulatory standards relating to the supply of water were met. And for this purpose, if we could turn to ISTRP quadruple 0 0005/48. In this part of your report, you provide usefully an overview of the relevant statutory and regulatory standards that apply to the provision of water. I'd like to go through those standards that apply to various aspects, such as water pressure, flow rate, and the rest of it. Turning first, though, to water pressure, you set out at paragraph 2, which starts at line 7 on that page, this: the Water Supply and Sewerage Services Customer Service Standards, Regulations 2008, the GSS regulations, require a minimum pressure of 7 metres, 0.7 bar, static head pressure in the communication pipe supplying premises with water. Ofwat, the water regulator, also refers to, quotes, a reference level of service, close quotes, of 10 metre pressure on the customer's side of the main stop tap. Due to the practical difficulties of measuring pressure there, Ofwat suggests that water companies instead use a surrogate measure of 15 metre pressure head in the adjacent distribution main, and this is common industry practice. And if we could go to page 234 of chapter 6, which we find at ISTRP quadruple 0 0008/234. At paragraph 6.9.6, you set out your conclusions in relation to the pressure levels on the 14th of June 2017, and we can see at paragraph 29 at the foot of that page this: I mathematically simulated the pressure heads at each hydrant used by LFB to supply water for firefighting on the 14th of June 2017. The lowest estimated pressure head is 25 metres, 2.5 bar, for the fire hydrant H8. The pressure head at hydrants H1, a fire hydrant, H3, a fire hydrant, and H5, a washout hydrant, varied between 29.4 metres and 35.8 metres pressure head. That's 2.9 bar to 3.5 bar. And you go on to say these minimum pressure figures on the 14th of June exceeded, indeed comfortably exceeded, both the 0.7 bar and the 1.5 bar regulatory standards. Is that a fair summary of your position?
It is.
Thank you. Can I now turn to water flow rate? And for this purpose, can we go to ISTRP quadruple 0 0005/48? And if we could look at paragraph 3 in particular. I don't think that's what we need. The reference ISTRP. Thank you. And if we could look at paragraph 3, you note there that section 38, subsection 1, of the Fire and Rescue Services Act 2004 states that, quotes, a fire and rescue authority must take all reasonable measures for securing that an adequate supply of water will be available for the authority's use in the event of fire. Elsewhere in this chapter, you note that, and I quote, the statute provides no further detail on what constitutes an adequate supply, and there is no minimum flow rate figure explicitly stipulated in the Fire and Rescue Services Act 2004. Now, there is guidance, I think you identify in your report, and if we look and continue in paragraph 3 on the page that's on the screen, we see at the end of line 21, you say this: the National Guidance Document on the Provision of Water for Firefighting recommends a flow rate of 20 litres per second to 35 litres per second, that's 1,200 litres per minute to 2,100 litres per minute, for multi-occupied housing developments of more than 2 floors, such as Grenfell Tower. Now, that's a long run-up to a question, which is looking at flow rate that was actually delivered to the tower. We referred to this briefly and earlier in your evidence. And can we go to page 231 of Chapter 6, which is ISTRP quadruple 0 0008/231. And we can see at paragraph 14, you state that, and I quote, the estimated peak fire flow used on Wednesday the 14th of June 2017 was approximately 72 litres per second, 4,320 litres per minute. Apologies for a very long run-up, but necessary to this question. The flow rate at Grenfell comfortably exceeded the recommended flow rate in the National Guidance Document. Is that a fair conclusion?
Yes, with a lot of caveats, but yes.
But essentially, yes.
Yes.
Now, if we can go...
Well, I wonder, that sounded like a rather guarded reply. You say with a lot of caveats. What do you... I think perhaps possibly we ought to know what you say about that.
I mean, I find a lot of these documents, they're first of all, they're not regulatory documents. They just provide recommendations in that respect, and there's a lot of ambiguity between these numbers. So if I take the number of the National Guideline Document for the Provision of Water, first of all, I've identified a number of limitations. It gives a certain flow rate between 1,200 to 2,400 litres per minute. So this is a very wide range. At the same time, that wide range, it doesn't really seem to match the predetermined attendance. Again, going back to my point that if the London Fire Brigade has predetermined attendance to deploy an aerial, and as we learned from the press very recently, they've purchased a whole set of new aerial ladder platforms, does that mean that you're purchasing a Rolls-Royce and you're driving this Rolls-Royce in the first gear because purely you don't have the capacity to utilize that equipment? And that's the kind of that's the caveats I want to put around. There are these numbers, but actually the meaning of these numbers, it's hugely questionable.
Right.
I was going to draw you now to the points which you would want to caveat that with, so I was kind of getting to those questions now. If we can go to ISTRP quadruple 0 0005/14. I think really I want to take you through the issues which you say the guidance document doesn't take account of, but it should, in order to provide, I think, a more satisfactory or tolerably reliable figure. And in essence, we can see from the underlined subheadings on that page the facts and matters which you think ought to be accounted for, which aren't. First of all, the size of the building. Secondly, the building materials used and the extent of compliance with building regulations. Thirdly, the presence of fire protection systems such as sprinklers. And finally, whether or not an aerial appliance is required. Are those the particular points which you feel the National Guidance Document ought to consider, but it doesn't?
Correct.
The final matter I'd like to take you to is the quantity of water and compliance with regulatory standards in that regard. And to this end, can we stay in this particular chapter but go to page 48? And if we look at paragraph 4 at line 28 on that page, Dealing here, as the subheading indicates, with quantity of water, is it right to say that quantity of water is simply about there being enough in the system, so it's not going to run out, whereas flow rate is about how much water can be delivered at any particular given time?
Correct.
Now, your report addresses the available quantity of water on the 14th of June on page 229 of Chapter 6, which we find at ISTRP quadruple 0 treble 0 8/229. And if we look at paragraph 2, the report lists the sources of water which supply the Barrow Hill zone in which the tower is found. And at paragraph 3, further down the page, you say this. The average daily demand for the Barrow Hill zone in 2017 was estimated at 116.58 megalitres per day, or the equivalent of 80,958 litres per minute, 1,349 litres per second. In comparison, the maximum flow rate used by LFB for firefighting on the 14th of June 2017 did not exceed 4,320 litres per minute, about 72 litres per second, and this water flow rate for firefighting peaked at hours of minimum water consumption. And then if we go slightly further down the page to paragraph 5, you concluded thus: the Barrow Hill zone had no water storage and or water availability constraints to be able to meet and significantly exceed the water demand for fighting the fire at Grenfell Tower. Now, in your view, therefore, is it safe to say that the quantity of water available for firefighting was more than adequate?
Yes, definitely.
Dr. Stoianov, those are all the questions I have for you now. Sir, might I ask for the usual break of, say,
Yes.
quarter of an hour to see whether I've missed anything or to see whether any particular points that anyone else would like me to raise?
Yes, very well. Well, Dr. Stoianov, when we get to this stage and counsel thinks he's asked all the questions he ought to ask, we always have a short break to give him a chance to check that he's not overlooked anything,
Okay.
and also to give other people who are following the proceedings from elsewhere the chance to suggest questions which perhaps ought to be put to you. So we're going to break now. We'll resume at 20 to 3, please. And at 20 to 3, we'll see if there are any more questions for you.
Okay.
All right? Thank you very much.
Thank you.
Thank you very much, Mr. Kinnear. 20 to 3.
Thanks, sir.
Yeah. Would you ask Dr. Stoianov to come back in, please? Right, Dr. Stoianov, let's see if there are any more questions for you, shall we? Yes, Mr. Kinnear?
So thank you for the further time. I have no further questions for you, Dr. Stoianov. So it just leaves me to say thank you very much for providing such a comprehensive report and indeed a further supplemental report and for attending to give evidence today. It's very, very much appreciated.
Thank you.
Yes, and it's right that I should say thank you as well, Dr. Stoianov, on behalf of 3 members of the panel. You've done an awful lot of work on this matter with great care, as we can tell from your report. And it's been very interesting to have the chance to hear you in person as well. So thank you very much. We've benefited greatly from your evidence, and we're very grateful to you for coming to give it. So thank you very much.
For the opportunity as well. Thank you.
And you're free to go. Thank you.
Bye-bye.
Yes, Mr. Kinnear. Well, that's all we have for today. Is that right?
That's right, sir.
So we shall finish at that point. But tomorrow we have another expert witness coming to give us his evidence, and we shall look forward to seeing him. I think it is Dr. Bisbee, isn't it?
It is.
Professor Bisbee.
Professor
sorry.
Bisbee, yes.
Tomorrow. Good. And we'll do that at 10 o'clock tomorrow morning.
Thanks, sir.
Thank you very much. 10 o'clock tomorrow morning. Thank you.